Alright, in this video we're looking at composite functions. So this first one here, for example, f of g of x. Another way to think about this is it is f of g of x. Those are two different notations meaning the same thing. So basically what you do is you plug in f and then you put in g of x, so 3x plus 1. Now normally what f does is it sort of takes x and it sends it to x squared. You can think of a function as doing that to x. So when we apply f to 3x plus 1, it takes 3x plus 1 and squares it. So that's what f of g of x means. Now, it doesn't work in reverse the exact same way. So it does matter what order you compose functions in. So g of f of x is going to be g of f of x. F of x is x squared. And then to do g to something, you can think of it like this. G will take in an x value and it will send it to 3 times that x value plus 1. So if we plug in x squared to that, it's going to do 3 lots of x squared plus 1. So that there would be g of f. And you can see that those two are not the same function. Okay, g of f of 1. So there's 2 ways you can do this. G of f of 1. That's going to be 3 lots of 1 squared plus 1, which is 3 plus 1, which is 4. The other way to think about g of f of 1 is you can actually work out f of 1 first. So that's going to give you 1 squared. So that is just g of 1. And then you're going to get 3 lots of 1 plus 1, which again is 4. So you can work out the number first and plug it into g. But since we've already got what the function is, we can sort of use that there as well, save a bit of time. G of g, you can actually compose a function with itself. So g of x is going to be g of 3x plus 1. What does g do? It does 3 times what you put in. So we're putting in 3x plus 1 to that, and then adding on 1. So that's going to give you, if you expand it out, 9x plus 3 plus 1, or 9x plus 4. So you can compose a function with itself as well. Okay, so a couple questions here. Find f of g for this one. So f of g of x is going to be, let's see, g of x is sine of x. So we're going to have f of sine of x, just like that. And then what does f do? It squares things. So we're going to get sine squared of x. Or if you like, this is another way of writing sine of x all squared. It's just like a notation thing there. Okay, we'd like to state its domain and range. So, well, what can we put into sine? We can put anything. So the domain there will be that x is in R. So x can be any number. And the range, well, what values can sine squared spit out? Well, sine is usually in between -1 and 1. And then when we square it, any negative numbers are going to go positive. So it's just like that. So that's our range. So 0 is less than y is less than 1. Okay. Find g of f and let's state its domain and range. So g of f of x is going to be g of x squared, which is going to be sine of x squared. Okay, so a little bit different to what that original function was. So you can think about it, the domain, again, we can just plug in any real number. And for the range, we're just going to have a sine value. So sine of any real number is -1 up to y up to 1. Because you're not squaring the sine value itself, sine can become positive or negative as the final answer. And just to confirm, we can see that sine of x all squared does only take on positive y values up to 1. And for that blue graph, sine of x squared, it can take on positive and negative. And both have that domain x is in R.